So welcome everyone. This is 3.4 on rational root theorem. This is part 2. We talked generally about what the rational root theorem does, and we took notes on them. And these are I'm going to go over 2 examples here. So in this example, we have to find the zeros and write in factored form of p of x equals x to the fourth minus 5x squared. So we're going to use the rational root theorem, right? The all possible rational root list, or A, P, R. That's going to be the factors of your constant, which is positive 4, over the factors of your leading coefficient, which is 1, right? So when we are doing this, and we're finding all possible rational roots, and my denominator or my leading coefficient is 1, I don't really think about it, okay? Because whatever the factors of 4 is divided by the factors of 1 is just plus or minus 1, right? So it's just going to be the factors of 4, okay? So whenever your leading coefficient is 1, you just kind of switch it away, all right? So my possible rational root list is going to be plus or minus 1, plus or minus 2, and plus or minus 4, right? Because those are all the factors of 4. 1 times 4 and 2 times 2. So I have that, and then I'm going to do division. I want to synthetically divide. So here, I'm going to try 1. Here, just getting my coefficients at 1x to the fourth, so it's 1, negative 5x squared. Wait, I need a filler, right? Between the 4 and the 2, right? The x to the fourth and x squared. So it's a 0, negative 5, x squared. I need an x value, so it's a 0, and then it's going to be a 4, right? So I drop down the 1. 1 times 1 is 1. 0 times 1, or 0 plus 1 is 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 0 plus negative 4 is negative 4. There's going to be my remainder. 1 times negative 4 is negative 4. 4 minus 4 is 0. Right? So I went fishing, and I got it my first try. Okay? So if 1 is a root, then what's my factor? X minus 1. Okay? And then I would have a 1. I'm going to do this in pencil. A 1, a 1, a negative 4, and a negative 4. Right? So since this is going to be x to the fourth, I just go 1 below that, x to the third. So that's x to the third. So I got 1x to the third. I got plus 1 x squared minus 4x and then minus 4, right? But notice, yeah, I cannot factor this out, right? And I can't factor out an x cubed. So I got to do this process over again, okay? Sometimes you do luck out because you don't need another of these. If your constant was different, and if your leading coefficient was different, then we would need to make this list. But since they're the same, -4 is the same thing as the factors of 4. Yeah. And 1 would still be the factors of 1. You could just use this list. Okay. So from here, I would go 1, 1, -4, -4. You could test out 1 again if you wanted to, but the chances are greater it's going to be something different. So I'm going to try 2. Okay. +2. So 1 goes down. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -4 plus 6 is 2. 2 times 2 is 4. You're left with a factor or a remainder of 0. Okay? So we're good with that. Now, the factored form, if x minus or if 2 is a root, then what's my factor? X minus 2. And then this x minus 1 just drops down. Okay? And then I have a 1x squared. Because this is x to the third, you just go 1 below that. Plus 3x plus 2, right? So we're left with that, right? I factored it twice. Now, x squared minus 3x plus 2, you guys can factor that in your sleep, correct? What are the two numbers that multiply to 2 and adds to 3? 2 and 1. So it's plus 2 plus 1. And then that's my factored form then. My factored form, P of x equals x minus 1 times x minus 2, these two guys here, times x plus 2 times x plus 1. Okay? That makes sense? Yeah? Pretty simple. So we got to find our zeros. Finding our zeros make P of x equal to 0. Like that, right? So it's going to be 0 equals all of those factors when you multiply them. So I know x minus 1 can be 0, or x minus 2 equals 0, or x plus 2 equals 0, or x plus 1 equals 0. So that when you solve that, x equals 1, x equals 2, x equals -2, x equals -1. Those are all my zeros. Okay? And I am done with the problem. But I want to extend this idea out a little bit. Okay? I'm going to go ahead and graph this. All right? So when we go and graph it, we need our end behavior. All right, let me put it up all the way there. We need our end behavior. We need our y-intercept. And I already have my zeros. And we need the multiplicities of the zeros, right? So the end behavior here, the degree is 4, so it's even. My leading coefficient is positive. So positive, even, what is my end behavior? Both up, 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 right? So I'm going to just, at the tail ends of this graph here, I'm just going to make it up and up, okay? At the ends of it. That's my end behavior. Check, I'm good. So my zeros are 1, 2, -2, and -1. So -2, -1, 1, and 2. Those are my zeros, right? What's my y-intercept here? 4, because you're going to make x equal to 0. So that's a 0, that's a 0, and then you're just left with your constant, 4. So 1, 2, 3, 4. There. Yeah, so it's going to go through all of these points, and the multiplicities of these zeros are all 1, right? So that means that it's going to go through, okay? If it's an even multiplicity, it's going to bounce or touch, all right? So if it's an even multiplicity, my graph is going to come around here and touch it and go back up, okay? Go back to the same direction. It's going to make a parabola at that point, okay? If it's odd, like this one is, it's just going to go through it. You're going to go through the point like a line, all right? So that's how you just think about it. So we're done with all the key points. So we start off with my end behavior here, and we're going to go off down towards this 0. I know that 0 has a multiplicity of 1 again, so it's going to go through it. So it's going to go through this point. But I know I'm going to eventually have to come up and hit this 0, right? So from here, I'm just going to come up and hit that 0. Again, the multiplicity is odd or 1. So it's going to go through. And then my next point from left to right, I'm going to hit that y-intercept. I'm going to hit the y-intercept, but I know I have to come back down and hit this 0. So it's going to come down and hit that 0. Multiplicity is 1 again. So it's going to go through. And I'm going to have to come back up and hit this 0. So that's what I did. It's going to go through it and then just go off into the sunset towards my y-intercept or my end behavior to the right. Okay? All right. So it should look more like a W. I still want to draw a picture right now of a cow. Like, okay. All right. We're good with this one? Yeah. But honestly, class, I want to cover this problem again, the same problem, but I want to approach it a little bit different. Okay. I'm going to approach it side by side with another polynomial. Okay. Can we factor this? Oh, no, not squared. Can we factor this guy here? Can I factor that here? Yes, no, maybe so. Yes? So two numbers that get me a product of -4 and a sum of -5. -4, -1, yeah. Right? -4, -1. Correct? Yeah. We all know that. This, we can also factor. Because this middle term here, the x squared, is half the size of my leading coefficient, we can factor it. X to the first is half the size, or is half x squared. Or x squared is half x to the power of 2 equals x squared, right? X squared to the power of 2 equals x to the fourth. If they have that relationship, where if you square it, the variable becomes your leading coefficient, right? Then you can factor. The only difference between factoring this and factoring this is the x's, right? The x and the x becomes an x squared and an x squared. Instead of an x and an x here, it becomes x squared because this is x to the fourth. Okay? The numbers are the same. -4, -1. Okay? So if I just factor this out, I could also get my zeros. What does x squared minus 4 factor out to be? Close. X minus 2 and x plus 2. That's a difference of squares. Okay? The form would be a squared minus b squared equals a plus b times a minus b. Okay, so x squared minus 1 breaks out to be x plus 1 times x minus 1. Okay, and then we have the same thing, same factored form here, just in less steps. Okay? Questions? Yeah, and then we'll still do the same thing from here on out. All right? Yeah. This is going to be number 43. P of x equals 3x to the fifth minus 14x to the fourth minus 14x to the third plus 36x squared plus 30, oh no, not 36, 43x plus 10. It's a big one. Okay? So we're going to do the same steps as before and get your possible rational roots. That's going to be the factors of your constant, which is 10, over the factors of your leading coefficient, which is 3. Factors of 10 would be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, right? Over plus or minus 1 and plus or minus 3, correct? So your APRR is going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Because if I divide all of these numbers by 1, I get the same thing, right? And then 1 divided by 3 is plus or minus 1/3. 2 divided by 3 is 2/3, plus or minus 5/3, and plus or minus 10/3. Oh, not 10 over 13, but 10/3. Okay? Cool. So this is going to be a long one, a long day of fishing. Okay? So I have 3, -14, -14, 36, 43, and 10. Okay. I'm leaning, honestly, towards using one of these fractions. And I'll tell you why. Because these numbers are so big, right? 3, 14, negative 14, negative 14, 36, 43, and 10. I want to make them smaller. That's where I'm leaning. Yeah, that's my train of thought. Um, I'm going to go ahead and try 1/3. Okay. So when I put 1/3 in there, 3 drops down. 1/3 times 3 is, just cancel out the denominators, 1. Negative 14 minus or plus 1 is negative 13, right? I'm just going to stop right there. Why am I going to stop right there? I know that this is not going to work. It might, right? You might get that one when you go out fishing. You might get that 100-pound fish, right? So 1/3 might work, but I'm not going to waste my energy doing 1/3 times negative 13. Whenever you're multiplying by a fraction, right? And whatever you're multiplying by is not a multiple of 3, I'm going to stop. Or it is not a multiple of your denominator, I'm going to stop. Again, it might be, right, if you keep going. Yeah, but most likely it's not. Yeah, so I want to play the percentages here. I'm just going to stop. Because again, I don't want to put my energy into trying to do 13 over 3 or negative 14 minus 13 over 3. If you did, this would be negative 13 thirds, right? Yeah, I'll show you the energy that you guys would expect. Negative 14 is 42 over 3. Negative. So then this would be 55 over 3 negative, right? And you have that what's going on face. Yeah. Because I'm not going to, again, do this again and then hope for, I'm not going to spend my energy that way. Okay, so once you hit a number that is not a multiple of your denominator, I'm going to stop. Okay, so I know I'm going to have to use that first row again. So I'm going to highlight it because I want my eyes to go there. Right? Okay, I'm going to try negative 1/3. Maybe that'll work. 3 drops down. That's negative 1. Negative 14 minus 1. That's negative 15. Negative 1/3 times negative 15. That's still a multiple of 3, so I'm still good. Is going to be 5. Everybody agree it's going to be 5? Okay, 5. Positive 5 because a negative times a negative is a positive. Negative 14 plus 5, that's negative 9. I'm still good. Right, I'm still alive. Negative 1/3 times 9, that's going to be, or times negative 9, that's going to be positive 3. 36 plus 3, that's 39. Still good, right? 39 goes into 3, yeah. 13 times. So that's negative 13. 43 minus 13, that's 30. Positive 30. I'm still good. That times that is negative 10. And then 10 minus 10 is 0. Okay? So we have this. And 1/3, negative 1/3 works. All right? So negative 1/3, if negative 1/3 is my root now, what's my factor? Who wants to say x plus 1/3? Yeah. Yeah, that's how it starts. Okay? You can say x plus 1/3. But do we ever use it this way? No, have you ever seen it in this form? When you have a denominator, this denominator just travels up here. So it's not x plus 1/3, it's 3x plus 1. Okay? You will get 1/3 or negative 1/3 as x if you solve that for 0. Okay? If you set that equal to 0 and solve it, I mean. All right? So now we have 3, negative 15, negative 9, 39, and 30. So I started off with x to the 5th. So this is x to the 4th, x to the 3rd, x squared x, and then plus 30, right? And then doing this over again, okay? So it's like number 43, factor this out. 43a, factor this out. Okay, we're going to do the same thing here, okay? So start from the top, APRR, factors of 30, and the factors of 3. Factors of 30, you can honestly, like, just get another sheet of paper. Right? And let's go factors of 30 is 1 and 30, 2 and 15, 3 and 10, 4, no, 5 and 6, 7, no, 8, no, and then we're done, right? So the factors of 30 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 10, plus or minus 15, plus or minus 30, all over plus or minus 1 and plus or minus 3, right? So my APRR, or all possible rational roots here, would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 10, plus or minus 15, plus or minus 30. And then 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 3 divided by 3 is 1, which I got already. 5 divided by 3. 10 divided by 3. 15 divided by 3, which is 5, which I got. 30 divided by 3, which is 10, which I got. Right? So that's my list. All right? So that's 3, 3. I'm just going to write out the coefficients here and then turn my page. Negative 15, negative 9, 39, and 30. So when I go fishing, 3, negative 15, negative 9, 39, and 30. I don't know why I put a comma right there. Okay? I'm going to try 1. So a 3 drops down. 3 times 1 is 3. That's negative 12. Negative 12. Yeah. That would be positive 21. Or negative 21, I'm sorry. That's negative 21. That does not work. Right? That would be 8, 18. No, that doesn't work. Let me check. Oh, class, here? What can I do? What can I take out of a 3x to the 4th and negative 15x cubed? A 3, right? I'm just going to do that at first. So it's a 3x plus 1. I'm going to take out the 3 out there in the front. That's x to the 4th minus 5x to the 3rd minus 3x squared plus 13x plus 10. Right? So you got to keep in mind that it's the factors of 10 now and not the factors of 30. Right? Over 3. So in my list, I can just get my list. I can cross that out. I can cross these two guys out. It gets smaller. I can cross out all the fractions because my coefficient here is 1 now. Right? So it's just the factors of 10, which is not 3, but 1, 2, 5, and 10. Right? So by taking out that 3, I actually shrunk my list that I have to do by a lot. Okay? So now the coefficients will be 1, negative 5, negative 3, 13, and 10. Okay? So 1, negative 5, negative 3, 13, and 10. I'm going to try a 2. Okay? So 1 comes down. 1 times 2 is 2. That's negative 3. That would be negative 6. That's negative 9. That's negative 18. That's negative 5. That would be negative 10, and it'll be a remainder of 0. Right? So I have a 3x minus 1. Is it minus 1 or plus 1? The previous one that we believe it was a plus 1. Because we took out a minus, right? A negative 1/3. And then since 2 is one of my roots, then x minus 2 is my factor. And I would have 1 x to the 3rd minus 3x squared minus 9x minus 5. Okay? So I took out both of these guys. I factored these guys out. And then we'll repeat the process again. But it gets smaller and smaller, which is a good thing. Right? APRR is just going to be plus or minus 1 and plus or minus 5. right? Because that's -5 and that's 1. So 1, -3, -9, and -5. I want to try -1. So 1 comes down. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is +4. That's -5. That's +5, and that's a 0, right? So we got our last one that we have to get. So 3x plus 1 times x minus 2 times x squared minus 4x minus 5. Oh, I forgot the x plus 1, right? If -1 is a factor or is a root, then x plus 1 is a factor. Factoring these two guys, that would be a -5 and a +1, right? So here, I have an x plus 1 here and an x plus 1 here. I want to put those two together. They combine and make x plus 1 quantity squared. Okay, so this 0 actually has a multiplicity of 2. Okay, rewriting everything else with the 3 that I pulled out. That's by P of x. That's by polynomial in factor form. Cool? So my zeros will be x equals -1 with a multiplicity of 2, x equals 1/3 negative, multiplicity of 1, x equals 2 with the multiplicity of 1, x equals 5 with the multiplicity of 1. Okay? Last thing I promise. My original problem, I don't remember, but what I do remember is my leading coefficient. My original unfactored form was 3x to the 5th. I don't remember these numbers here, but I do remember the constant was 10. Okay? So what's my end behavior if I wanted to graph it? My leading coefficient is 3x to the 5th. What's my end behavior? With your arms. What is my end behavior? Yeah, it's like this, right? So my end behavior there would be this side going up. It's positive odd. So, and it goes like that, right? Okay. What's my y-intercept? My constant would be 10. Okay. I'm going to graph all of my zeros. So that's 1. I want to make every 2 blocks on my y-axis 1. Okay. So that's -1 right there. -1/3 would be like here. -2 or +2. 3, 4, 5, 3, 4, 5. 5 will be there. Okay? All right, and then I'm ready to graph. So I'm gonna start off with my end behavior. End behavior negatively. Going towards -1. My multiplicity is 2, right? So I'm gonna actually bounce off of that and come back to the same direction. I'm gonna have to come back up to hit the 1/3. Everything else has a multiplicity of 1. So I'm gonna go through it. I'm gonna come up all the way to 10. Go through that, but I eventually want to come back down to 2. Go through that. Go to 5. Come back up to 5. Go through that to my end behavior. Okay? That's how you would graph it. All right, and that's the lesson for today. Hopefully that made sense.